right? So this is our second face-to-face lecture. Although medyo kahit CS class siya, it is really designed actually as a lecture class. Kaya napansin nyo maraming lecture. Although we changed the format a little bit to make it more, we're learn from home friendly. Okay? So just as a note na rin, again, for those of you who just came in, lahat ng quizzes, lahat ng assignments, open notes. So walang closed notes. Ha? So that's one thing to remember. Two is, were you all able to acquire the crimping tool, RJ45 cable, and the stuff? Like, those of you who have problems, just let me know. Okay? So I'll just assume you're all okay with that. If there's an issue, just let me know. Basta you will also see that your CS154 lab will already start this coming So share that in So if you look at the schedule for week number 2, these are activities that we're going to have. So we're going to do this lecture. We're going to cover as much of set 3 and set 4 as possible. We may not be able to finish, so just take note na lang of the material. Right, so very clear-cut naman yung material. Right, so that's on the Then this is the crimping, the video on how to do crimping. I didn't make this, but it is fairly representative of what you need to do. There's also a documented instruction. There's also the cabling convention. This is the actual instructions for the laboratory exercise, and this is laboratory exercise number 1. So you notice it's due on September 28th. So please take note of that particular deadline. Okay. Tapos for week number 2, you also have, as usual, meron kayong isang quiz, tapos 2 assignments in quiz format, right? So if you notice, most of our assignments are actually in quiz format. So they actually have time limits, but the difference lang, the assignments you can take for the whole week, the quizzes you only have to take right before class. So like, for example, quiz number 1 was the first thing you took. Tapos, another announcement I'd like to make is you probably realize also this class has badges, right? So some of you have already earned your first few badges. So these are the badges for the entire class. Let's show you a better looking summary, right? So some of you have already earned it. You watch a video, you do certain things early, you actually get badges for that, right? So the whole semester is already programmed in. A lot of the things are already accessible. The assignments you can actually take early. The only thing you cannot take early are the quizzes, so they are time-bound. Okay, and the deadlines, of course, are time-bound. So at least if you feel you want to take the materials earlier, feel free to do so. Okay? Questions so far? Excellent. Okay, so may question, chat na lang kayo, or please feel free to speak out kung meron kayong questions, kasi sometimes I can't see the chat. Okay, so let's start the lecture kasi medyo wala tayong masyadong time. So do you all see the slide set number 3, transmission media?
Yes, sir.
All right, excellent. So we'll start the lecture. So last meeting, we discussed how data networking works and how do we describe network. So we talked about bandwidth, latency, we talked about simplex, duplex, so different ways about talking about networking. And we even talked about how do you squeeze as much information into certain media, for example, like wireless or wired, by using multiplexing techniques, diba? Frequency division multiplexing, time division multiplexing, and the like. Right, so a lot of these multiplexing techniques are actually quite useful to us, right? And that's the reason why we can actually carry a lot more data than what we would do if we were only to put one stream of information through that particular channel. Right, so now we're going to discuss the transmission media itself. What actually carries this information, right? And that is the topic of today. Also, if we have time, we're going to discuss the ISO OSI system. So this is the standards, the standard in which the standards are based on networking. So we discuss an introduction to networking protocols, which will actually be majority of this class, okay? Because we have to agree on how we communicate in order to communicate properly, okay? So first up, let's go this, right? So we discussed this last meeting, and this is just a quick review. So we cannot discuss transmission media without really discussing what are the factors that affect transmission media. So think of transmission media as the path between the transmitter and the receiver. This can either be a physical path like a wire, or it can be a wireless path, right? Like air interface like Wi-Fi and the like. Do you hear the background noise? Hello?
Yes, but that's the soft.
Soft lang. Okay. Because my neighbors have decided to become noisy today. Right? So, no. So, since soft lang, and my voice is louder, so I think we shall just soldier on. Okay. So, in terms of transmission capacity between 2 points, there are things that affect transmission capacity, and let's just discuss them clearly. So, impairments are things that affect the transmission capacity because they degrade the signal. So impairments can include things like if I am sending through a wireless interface and another wireless transmitter interrupts. This is like when I'm talking and somebody else talks, like my neighbors are being noisy, that is an impairment, right? So impairments can actually make your network slower, right? And they cause errors because a 1 can become a 0 or a 0 can become a 1, right? The most common types of impairments are the four types of impairments we see here. Attenuation is the loss of signal over distance. Why does this happen? Because, for example, if I send an electrical signal through a wire, over the distance, the electrical signal gets smaller. And the reason being is because of resistance. Siyempre, yung electrical wire, meron siyang internal resistance. Hindi naman totally zero. No matter how good the conductor is, there is some resistance. And that is what we call attenuation. Now, for things like fiber optic cables, there's no electrical resistance. But what happens, there's impurities in the fiber optic cable kasi hindi naman super pure yan that the light signal can go through a fiber optic cable without any attenuation. And that's the reason why there is signal loss over distance. And that's why up to a certain distance, you need a repeater to basically take the signal in, repeat the signal so that it is stronger at the other end, right? The second type of attenuation is what we call attenuation distortion. Because if we send signals over different frequencies, then they can be impaired in different ways because different frequencies are used. For example, lower frequencies are more prone to audible noise type, for example, impairments, while higher frequencies up to visible light are prone to opaque object blocking, right? So if you're at the, for example, the 5 gigahertz, 10 gigahertz range, it's more prone to a wall blocking the signal as opposed to, say, a microwave signal like 800 megahertz. 800 megahertz, kahit may wall na nakaharang, usually lumulusot pa, right? So that's different types of losses because of different frequencies. The third type is what we call delayed distortion, right? This is like your satellite communications that I mentioned last week, right? If I am talking, it takes time for the signal to go up and it takes time for the signal to go back down. Then, of course, last but not the least is noise. This is what I'm talking about. If I'm talking and my neighbors are talking, that is noise. If I am listening to a radio station and I drive by another radio station, there you can also hear some interference done. That is also called noise. Okay, so these are the four major types. And as we discuss the networking media later, we will revisit these types of impairments. Okay, and this is just a description of each. Attenuation is over distance, right? That's why there are repeaters. So you probably see, so I took this picture of my neighborhood electric post. So you will see here, this is an example of a repeater. The signal, the cable comes in one end, cable comes in the other end. There's no other reason for this box, right? Except that it amplifies the signal, right? So this is an example of a repeater in real life. Okay. Now, the last type of impairment is what we call noise. Now, noise, maraming klaseng noise, right? So there's what we call thermal noise or white noise. No choice. Thermal noise exists no matter what. This is the noise that was made at the birth of the universe and it just exists. That is the reason why in old television sets, if you turn on the TV at walang signal, you see that grainy static thing. That is what we call white noise. So no matter what you do, no matter how quiet the electromagnetic signals elsewhere are, you will always see white noise. Yung nga, that grainy thing you see, that's actually white noise. Okay? The second type is intermodulation noise, meaning if you move from frequency to frequency, the act of moving creates noise. right? So that's what we call intermodulation. Crosstalk is a form of electrical noise. So this one is due to Maxwell's equation, so Maxwell's laws. If you have a current moving in one direction, you generate a magnetic field going in another direction. We talked about it last week, di ba, on why parallel electric circuits have a problem over distance is because of crosstalk, meaning you have your signal going one end, you have magnetic fields generated that goes around the signal that interfere with each other. Yan, tawag dyan, crosstalk. Now, crosstalk can be solved by crisscrossing cables, which we will discuss later. So that's a third type of noise. And the fourth type of noise is the noisy neighbor noise, which is what we call impulse noise. They just happen because they happen. Or, for example, you have an electric wire. Say sa bahay nyo, meron kayong wired connection and it passes through an inductive workload like a electric fan or an air conditioner. Nagcreate din ng noise. The signal actually degrades as if you run the cable beside anything with a giant motor. So things with motors are your refrigerator, aircon, electric fan. Yan, may mga motor yan. There are very little devices naman sa bahay na may motors, but if you run a cable through them between you and your transmitter, you normally have impulse noise. Okay, so those are the different types of noise and impairments in general. Now we will talk about transmission media specifically. Now there are two major classes of transmission media, wired and wireless. So wired simply means there is a conductor, whether it's an optical cable or an electric cable like a copper wire, silver wire, aluminum wire, or gold wire. These are all wired or guided media. That means the signal is carried by the conductor, right? That's why it's also called conducted media, but we generally call it wired, right? Then there is unguided media or wireless. It does not use a conductor, but it uses radio waves instead. Now, the thing with radio waves is it has to be shared by more users. That's the reason why wired media usually can carry more data reliably than wireless. So wireless is not innately less reliable. It just so happens that there are just more users who generally have to share a particular wireless connection. All right. So questions so far on impairments and wired and wireless? Okay. So let us proceed. Okay, now let us discuss more in detail about guided or wired media, which is really, there are
Sir, I
more
have a
kinds of
question.
guided or media. Oh, sige, go ahead.
What about yung mga parang Wi-Fi modem na that can be both? So is it part of both? Parang may
Yeah,
line cable.
so yung Wi-Fi modems, what we call Wi-Fi routers yung tawag dyan sa bahay, di ba? The ones you buy and you put them in the house, is because they normally have wired, meaning from your ISP to your wireless modem, that's wired usually, di ba? So usually it's either a fiber optic cable if it's a GPON or FTTH, or it's a coaxial cable if you're using cable modems, or if you're connecting from another modem, you have a UTP cable. So wired yung portion na yan. But the wireless router itself has an antenna and emits a wireless signal. Kaya that device is both wired and wireless. Now, just to avoid code confusion, right? We normally talk about devices separately than when we talk about media. So our lecture next week will talk about these devices, including your wireless router. So we will talk about that next week. Now, a device can carry or can use multiple media, right? So hindi naman kailangan na meron akong router, wired lang siya lahat or wireless lang siya lahat. So usually most devices can carry both. Okay?
Thank you, sir.
Right. Sige. Right, so guided transmission media, there are generally three major classes of guided transmission media. So for data communications, of course, in reality, there's more. There's your electric cable, there's your cable that connects your monitor to your CPU and things like that. There are many kinds of guided or conducted media or wires. But for network communications, we generally talk about three classes: the twisted pair wire, coaxial cables, and optical fiber. Right, the fastest growing one is optical fiber. So first, let us talk about twisted pair wires. So twisted pair wires are basically made out of copper wires. These are two insulated copper wires arranged in a regular spiral pattern. So you notice in this drawing, you see a spiral pattern. The wires are not straight. Diba? They're not parallel to each other, but they are crisscrossing each other. Why? Because of the right-hand rule. You see this thing, right? Maxwell's equation that creates crosstalk, right? If you arrange the wires in this way, you allow the magnetic fields to cancel each other out. If the electric signal goes in this way, the magnetic field goes around that one cable, then the return signal passes another way, and you have an electromagnetic signal going the other way. And since they are parallel to each other, they cancel each other out, right? So that is why you have different, say, categories of cable. Diba you see when you go to a store and you buy a UTP cable, like when you bought the cable for your lab, or as one of you mentioned last meeting in class, diba meron kayong category 5, category 4, category 6, category 7 cables. The difference in category is the amount of twisting that's done. The higher the category, the more twisting. The more twisting, the less prone to crosstalk, right? So the reason why twisted pairs are twisted is because you want to minimize the electromagnetic interference due to adjacent pairs, which is called crosstalk. Okay? Now, they're twisted, and the reason for this is they're using copper wires, so they're electromagnetic in nature. We usually use copper because copper is a very good conductor balanced with cost. You can always get a better conductor, say gold, for example, is a better conductor, pero siguro naman masyadong mahal yung wire natin kung gold yung wires, di ba? Kung gold yung laman ng wire. So we normally use copper because it's a good balance between cost and conductivity. All right. But for example, gold is used in high-end audio equipment. So if you buy high-end headphones, the wire for these things are normally gold instead of copper. So the more higher-end equipment, you can actually use gold because they're better conductors. Inside motherboards, for example, some of the circuitry between pieces of equipment or yung mga silicon on chip are actually made out of more expensive materials that have better conductivity than copper, right? But we generally use copper because of cost. Then, of course, copper cables or wires are made like how you make spaghetti, diba? You roll them until they're flat. So you have a big piece of copper, you roll it until it becomes flat, and that's how copper cables are made. Now, the only challenge with copper or electrical wires is this what we call a low-frequency transmission medium. So the amount of bandwidth that copper wires can carry is relatively low, okay, compared, of course, to the other types of media, right? There are two general variety of twisted pair cables. You have what we call STP or shielded twisted pair, or the most common one and the one we're going to use for the lab exercise called the unshielded twisted pair cable or UTP cable. So when you hear the word UTP cable, that means unshielded twisted pair. The reason why it is unshielded is because each wire is only insulated by a plastic wrap. So as you will see in your crimping exercise, there's nothing that separates the copper conductor from the outside world except a single piece of plastic. Which plastic naman is not cannot protect the wire from electromagnetic signals. And that's why if you have a UTP cable and you put it beside an air conditioner, then it will get affected by the interference. While shielded twisted pair naman has a metallic braid or foil around the conductor, aside from the insulation, and that's the reason why it is less prone to electromagnetic interference. You will see shielded twisted pair cables more in industrial use cases, inside factories, or inside sites or facilities that have a lot of electromagnetic signals around. But for general use, like you and me sa bahay, or sa school, we use unshielded twisted pair. As a matter of fact, in a general or a typical household, you do not see a lot of inductive workloads, right? You don't see naman big motors, for example, inside a classroom. Outside of the air conditioner, which in general is not really a big problem because the motor is normally, kung split type, the motor is outside, so it does not really cause interference. Then the interference brought about by an electric fan is very small naman, unless, of course, you wrapped around the UTP cable around the electric fan itself, which I suggest you do not do, okay? So this one are the different categories. So I mentioned a while ago, the difference between the categories is the amount of twisting. The more twisting, the higher the frequency. So you notice category here. So nandito tayo. Most of the things you can buy off the shelf is category 5E. As a matter of fact, if you ask, gusto ko po bumili ng internet cable, they will give you a category 5E UTP cable by default. And you notice the max data rate that it can carry is 1 gigabit per second. So that is more than enough, right? Of course, the higher the cable, it can carry everything a lower cable can carry. And that's the reason why you have 5E. So when one of you asked last week, pwede ba category 6 or category 5? Kung nagtitipid ka, of course, pwede. Right? Because for our lab exercise, most of the time, we only need up to 100 Mbps because of your laptop interfaces. The maximum is normally 100 Mbps. So there's a question here. Let me read that. So do wires have a lifespan? If yes, what usually causes it to degrade or something? Okay, so do wires have a lifespan? Now, in general, if the wire is made properly, it can last a really, really long time. So when you buy, for example, copper cables na nakabundle, yung mga warranty niyan, mga 15 years, 20 years, so it's a really long time. Now, sometimes kasi depending on the quality of the metal or the quality of the manufacturing process, sometimes they tend to be brittle. And that's the reason why they fail. Or sometimes the wire or the metal is okay, but the plastic shielding or the plastic insulation is the one naman that is not very made well. It's not made very well, sorry. Na bulol ako dyan. So it's not made very well. So sometimes nagde-degrade yung plastic. So yes, they do have a lifespan, pero usually matagal. Usually mga 15 years yan. I think the typical warranty for the cable is 15 years. The same thing for fiber optic cables. Normally yung plastic yung nasisira. Okay? Excellent. Okay, so the higher the category, the more data you can carry. But for us, for the typical you and me, 5E, 5 is fine. As a matter of fact, 4 should be fine, but you only get up to 16 megabits per second. Besides, you cannot buy a category 4 cable. But you can buy a category 1 cable, which is the one used for your telephone line. So you see the manipis na telephone wire? That's a category 1 twisted pair cable. Can't carry much, but it's okay. And besides, you know naman that the typical telephone wire, since E0 yan, di ba? That can carry 64 kilobits per second. 1 megabit is more than 64 kilobits per second. So a Cat1 wire is more than enough. Okay? So I just mentioned a while ago, shielded twisted pair is more expensive because of the insulation. There's a woven copper braid around the copper wire that makes it less susceptible to electromagnetic interference. Pero mahal siya. Right? So again, industrial use cases. So this is a factory. You notice these are large motors. And that's the reason why the wires that pass them tend to be shielded. Now, in reality, most of this is moving to fiber optic cables. So baka it might disappear. I mean, shielded twisted pair might disappear in the not so far away future. Okay, advantage of twisted pair cables is that they are cheap. They are readily available. You can go to your friendly neighborhood store. The retail rate is probably at 5 pesos per meter. I mean, if you just buy the cable wholesale. Of course, if you're buying it pre-crimped and with all of these like anti-breakage plastic stuff, then it will tend to be more expensive. Siguro you can buy like 2 meters na $100 siguro. It's probably what the going rate is already pre-crimped. The second reason is it's light and flexible, right? So again, copper wire, when you bend it, it does not degrade the signal because the signal, the electromagnetic signal, still passes through the electric wire kahit na nakabend yung cable. Therefore, making it easy to work with and install. So kung gusto mo pasikot-sikot sa loob ng classroom, mas madaling gamitin yung twisted pair cable. And that's the reason why classrooms, if you notice our classroom, for those of you who have seen our classroom, is you notice the cables going to the computer are twisted pair. Kahit na naka-fiber yung campus, the cables going to each individual computer is twisted pair because we have to pass through conduits and ducts and they have to go up to the computer, so they have to be bent, right? Now, the corollary is if you use a fiber optic cable, it can't be bent. But here, with twisted pair cables, you can bend it. You can bend it up to X degrees. It does not matter. Okay? Now, twisted pair cables, the disadvantage is, of course, susceptibility to noise and interference. There just so happens to be a lot more electromagnetic noise sources than optical noise sources. Then you have the attenuation problem. Since the copper or the material inside the wire has internal resistance, you normally have a maximum range. The general range for UTP cables is 100 meters, right? So anything more than 100 meters, the signal will degrade. So that's the reason why we recommend that people keep it. The maximum cable length is about 100 meters. And the bandwidth is relatively low. So if you notice in my table of categories, the bandwidth carried is relatively low, of course, compared to fiber. But compared to other media, like wireless, this is actually quite high. Okay? Now we move on to coaxial cable or coax, right? So coaxial cable is still made out of a metallic conductor. It still uses electromagnetic signals where the conductor is in the middle and there are insulation and coating and shielding around it, and that's the reason why it is coaxial. So it looks like this. So you see the copper core in the middle. You have some insulating materials. Then you have your ground, right, which is a shield. Then you have another set of insulating materials. So that's the reason why it's called coaxial, because it goes around this particular conductor. So the conductor is typically aluminum or copper, mostly copper because of cost. Now, the thing about coaxial cables is that they have shielding by default. Wala kang unshielded coaxial cable or shielded coaxial cable. It is always shielded by default. So this is how you would buy it, right? Now, the only difference is, of course, normally in the market, you can buy dual shielded or single shielded, but the ones you see at your home, if you have them at home, are normally dual shielded. Now, what is the most common coaxial cable use case sa bahay nyo? It would be your cable TV connection. So your connection from the cable TV provider would normally be a coaxial cable, right? So that is the most common kung sumisilip lang naman kayo sa bahay nyo. That is the most common type of coaxial cable, right? Again, there are two types of coaxial cable. For data networking, there's thin net and thick net, and they're differentiated by the thickness of the wire. Thin net is 0.2, is a quarter of an inch thick, and can carry up to a whopping 2 megabits per second. So even the slowest UTP cable carries 10 megabits per second. So UTP definitely carries more than thin net. But thin net, because it uses a coaxial cable, is less susceptible to electromagnetic interference. While thick net is half an inch in diameter, so it's thicker, twice as thick as the net, and can carry up to 10 megabits per second. So it will make it equivalent, for example, to UTP na category 5. Category, 4-ish. But UTP can only carry you up to 100 meters, period. Right? While coaxial cable being thicker, that means there's a lot more space for the electromagnetic signal to pass. Kaya 500 meters yung range. So the range is actually longer for coaxial cable. Right? Then, of course, we go on to the different types of connectors that are used for coaxial cables. Now, the most common type of connector is what you see on the screen right now, or what we call the bayonet nail concealment container, or what we call the BNC connector pala, not container, connector. Now, this one is what we call a BNC connector. It is the tip on one end of your coaxial cable. Then you have a T connector, which is basically spliced in the middle of this cable. One end is through the cable itself, and the other end to the other side of the cable. And the T portion, the junction below, is the one that's connected to your computer. Now, if you cut a cable and you want to reconnect them together, you use a barrel connector instead. And dapat at both ends of your coaxial cable, you put a terminator. And as I mentioned during the last week's session, this is actually used in bus type network topologies where you have a bus, right? You have terminators at both ends. You have a T connector, and in each T junction, you connect your computers or your devices. So that's normally how this would work in a coaxial cable setting. So medyo tipid siya kasi wala siyang hub or switch sa gitna. Okay? Now, coaxial cable grades, just to note lang, kasi there are two types of yung coating, right? The plastic insulation can either be PVC or plenum, right? So PVC is more flexible and it's normally used for exposed areas in the office. Pero there are normally some fire codes. So depending on the building you're building or the house you're building, you might have to comply with certain fire codes. And that's why if you put them inside for example, inside and not exposed, then normally plenum can also be used because they are fire resistant. Kasi PVC, plastic lang yan. So hindi siya fire resistant. Okay? Advantages of coax are bandwidth is relatively higher than UTP because the cable is thicker, right? However, it can easily be tapped, so that can be good or bad. Easily tapped means it's easier to handle, right? You can just cut the cable into two, add a T-connector, you add a node. Ang dali mag-expand. Just cut the cable, put a T-connector, then you can expand. The disadvantage lang is, of course, if you cut a cable, then everybody goes down. So medyo that's a disadvantage as well. And it is less susceptible to interference than twisted pair cables because it has insulation. Now, the disadvantage, of course, it's easy to tap is one of those disadvantages din kasi then it's easy to get disconnected. And as I mentioned last meeting, kapag sumipa ka lang ng computer that is connected to a bus type network using coaxial cables, ma-disconnect lang or malusan lang ng konti yung cable, you cut the cable, and therefore you don't have terminators at both ends, then your signal disappears, right? The high attenuation though makes it expensive. So since it is still electrical, may attenuation pa rin, you need more repeaters, right? Because it's very thick. It's either make the wire thicker, which is also cost, or you add repeaters in the middle, which is also cost. Tends to be bulky kasi may insulation, so it has a double layer of, it has shielding, so it has double layer of insulation, or it has quad shielding, and therefore it has quadruple layer of insulation. The data rate tends to be low. The fastest we normally get is 10 Mbps, and this is quite old technology. Yeah, it's not too common anymore. However, the cable TV industry has managed to push coaxial cable up to probably 50 megabits per second is probably what you can get retail for now, right? But for local area networks, 10 was the maximum, and this has practically disappeared for local area networks. So you will only see it in cable TV or cable internet use cases. Okay? Questions on coax so far? So essentially, it is still it's still metal insulation. Still uses copper, and that's the reason why all the pros of being copper apply. It's easy to work with. It can be bent. It can be folded. But the disadvantages are also there: electromagnetic interference and the like. Now we will discuss the third type of wired media, which is what we call the optical cable. Now the optical cable has this benefit because it does not use electric wires, right? It does not use electric conductors like copper. Instead, it uses optical fiber, which is basically uses light instead. Now, light, being light, can travel, of course, at the speed of light, and it is not prone to electromagnetic, or at least electric. It's not prone to electrical interference. So the distances can be longer. It can carry more bandwidth, right? Then off the top of the head, though, I'll tell you in advance, the disadvantage is you can't really bend it because of how fiber optic cables work, which we will discuss later. So in a nutshell, a fiber optic cable works by, on one end, you have a light source, which is an injection laser diode, which you can think of it as a really small flashlight, right? So on one end, you have a small flashlight. On the other end, you have a light, so one is the flashlight, the light emitting diode, and one is the one that reads the flashlight signals. So think of the LED as a little flashlight and the injection laser diode as one of those two ways of sending a signal. Then on the other end, you have a receiver that looks at the optical signals and translates it to bits and bytes, okay? So fiber optic cables use optical cable, not conductive metal cables, and they use light instead of electric signals. Therefore, it is not prone to electrical interference. Like coaxial cables, it is also concentric. You have a fiber core in the middle. You have a glass or plastic cladding. Again, it's also fiber, but a different grade of fiber, and I'll explain why in a little bit. And a plastic jacket. So that's why fiber optic cables tend to be thinner, because you don't need a certain thickness of cable just to send a certain amount of signal. So with coaxial kasi, the thicker the cable, the longer the distance. In fiber, actually, panipisan ng cable yan. The thinner the cable, the better. As a matter of fact, the smaller the core, right, the more bandwidth you can push through. And remember, the core in fiber optic cables is measured in micrometers. Okay, if you notice these fiber optic cables, if you've seen them, they are very, very thin. So for those of you who have fiber at home, you see the fiber optic cable that comes from your ISP into your house. Majority of that is actually the shielding, or what we call the jacket, right? So the jacket is actually thicker. The ones you see sa bahay nyo, that's what we call an armor jacket. Hindi lang siya plastic. That actually has an armor braid that makes it more resistant to breakage. Kasi of course, as you know, the cladding and the core are made of the fiber optic cables, therefore glass siya. So madaling mabalik. And because glass siya, you can't also bend it too far. Because if you bend it too far, it will also break. Okay? This is how fiber optic signals work. Now, we basically have the flashlight on one end and the receiver on the other end. You shine light on one end and the light actually bounces. Now, it would be great if the light were really, really straight. That's the best. But even though the light is not perfectly straight, it's okay because the cladding is of a different quality as the core. So the core is purer than the cladding. So what happens is you have a difference of refraction, right? So when the light goes through one end, it bounces off as if the cladding were a mirror. So even though you don't shoot the light signal straight, the light signal will definitely get out the other side. As a matter of fact, whenever we want to test a fiber optic cable, we simply get a flashlight, stay in a dark room, shine the flashlight on one end, the tip of the other end will actually light up, right? Because that's really how it is. You sense light across, right? So this is how it works. And this is also the reason why you cannot bend, the second reason why you can't bend fiber optic cables too much. The first reason is if you bend it too much, it will break. The second reason is if you bend it too much, then this angle will be wrong. So this cable can be so bent, right, that the signal can actually bounce back to the source instead of going to the other side. So that's the second reason why you can't bend it too much. As a matter of fact, the normal guidance is to not bend a fiber optic cable more than 45 degrees. So that's just the rule of thumb that we use. So you can't bend it. So this is 90 degrees, bawal na. So you can't even bend it more than 45 degrees. Okay? Now, there are three major types of fiber optic cables based on what the core is made of. Okay, multimode step index fiber is where the reflective walls of the fiber move light pulses to the receiver. So you bounce the signal off the walls, like my picture a while ago. So this is multimode, right? Now, there's step index and graded index. Step index is like this, it's sharp. Graded index is a little smoother, right? Then, of course, single mode fiber, which is the best, is the light goes down exactly the middle of the cable. So it looks like this. In step index, it's easier to make. You can make the fiber very thick, right? And the light can come in anywhere. It'll just bounce off the cladding and get to the other side. So therefore, the impulse pulse can be very high, but the output pulse is less because it has bounced off many times already. Now, if I make the fiber optic thinner, so this is 200 microns. If I make it about 50 to 100 microns, it becomes graded. The signal that comes in is, of course, strong. We will always make it as strong as possible. But instead of a sharp bounce, it's a graded bounce. Because, again, the thickness is smaller, right? The ability of having a very sharp angle of incidence is lower because the aperture in the inlet is small. Therefore, at the output, you tend to preserve more of the signal because it doesn't have to bounce off. Now, last is kung shoot siya sa gitna, which is like 10 micrometers or less, right? Here you can see that the signal is generally straight. That's why you can kind of preserve your signal as much as possible here, right? And that's the reason why this one can carry more bandwidth. Single mode fiber can carry more bandwidth. It is also much more expensive. And the distances can be longer. So for example, inside the Ateneo campus, the fiber optic cable used to connect buildings together are single mode fiber. We actually use single mode most of the time. Tapos may mga multi-mode ka lang na konti sa loob ng it's inside a data room. So to connect equipment together, that can be multi-mode. Or from room to room within the building, that can be multi-mode. But between the buildings, that is single mode fiber. And Ateneo made it a point to use fiber a long, long time ago kasi we always are prone to what we call electromagnetic disturbances like thunderstorms or lightning, right? And normally, if that hits the campus and your campus is filled with electrical cables, then it will naturally destroy equipment. At nangyari na yan a few times. Actually, some key pieces of equipment were destroyed in the early days of the campus network. And that's the reason why early on we migrated to fiber. As a matter of fact, Before year 2000, naka-full fiber na yung campus network na natin. I think 1999 was when it was fiber. Okay? Now, the nice thing about fiber technology is it seems to just be getting faster and faster, right? So you have like 10 million times growth since 1980 in terms of capacity and 10 times growth every year, every 4 years, right? So this is basically how it looks like. And this is in the non-WDM area. So WDM, or wave division multiplexing, allows you to send more signals inside a fiber optic cable. They have a term for that called coherent optical, where you effectively send different colors, right? So you can send different colors of light and they can represent different signals. It's another multiplexing technique, but it applies to fiber. So fiber is just growing fast. Now, in terms of milestones, in 1980, when the first fiber optic networks were created, they used something called X on or X off. This is effectively flashlight. Turning on is 1, turning off is 0. 1, 0, 1, 0. So that's what we call X on, X off, which is the default mode, right? Then, of course, in 1990, you see wave division multiplexing. Instead of just on and off with one color, you can actually use many colors. And with wave division multiplexing in the 90s, you can pack as many as 80 signals or 80 different colors inside the fiber optic cable, which is really, really nice, right? So different because they are shifted, right? Then, of course, in 1986, we have what is called an erbium-doped fiber amplifier. The reason why that's important is because, di ba, after a certain distance, signals degrade. Kasi fiber naman is not perfect, so it degrades din. So you have to put a repeater. In the past, the repeater had to be an electrical repeater. It would get the optical signal on one end, convert it to electrical signal, amplify the electrical signal with power, and send the signal back in, convert it back to optical, and send it out the other end. The problem with this optical electrical conversion, it is not the most efficient conversion because then you get bogged down by the speed of the electrical component, which is not as fast as optical, right? That's why these erbium doped fiber amplifiers are nice, is because you don't have to have an electrical signal. This also means that the repeaters can be floating in the middle of the Pacific Ocean without being powered. You don't have to plug it to an outlet. Mahirap yata maghanap ng power outlet sa gitna ng Pacific Ocean. So that is the reason why that is important as well. Okay? This is an example of what it looks like to do wave division multiplexing. So if you notice, wave division multiplexing, which uses, this is equivalent to your phase modulation, right? You change the phase. In this case, you see this is a 0, 0, 1, 0 in one phase. Then you see this signal is shifted by half, right? And this is how 0, 1, 0, 1 is sent. And this one is shifted by a whole, no, maybe 1/4, right? And you see the values as well. So this one is the two signals merged together. This is the information that's sent. You can get one from, you can extract one piece of information, one phase, a second piece of information from another phase. So that means you're sending this one signal, but you're sending 2 bits of information as opposed to sending 1 bit of information now. So QPSK is also important, and you'll hear this a lot because your mobile phones today actually use QPSK or better, or QAM64, which are just examples of wave division multiplexing or phase modulation. Different phases can send different signals. All right? Questions so far? So for fiber optic cables, capacity is bigger than both coax and twisted pair. It is smaller and lighter weight. It's smaller and lighter weight. It has lower attenuation because it's not prone to electronic interference, right? Because it is, again, fiber. It's not prone. So if you put it near an electrical source, an inductive motor, fiber won't care. Right? It has immunity to what we call environmental interference because it uses visible light. Therefore, as long as the insulation is properly coated and it's dark, then you will have no interference. But of course, it is also easy to destroy, right? You just put a nick in the insulation, and if light comes in, then the whole cable is destroyed, right? It's also easy to break because fiber is actually more breakable than copper because copper is malleable and fiber is not. Making it highly secure because if somebody tried to tap a fiber optic cable, it's more likely to break than the adversary being able to successfully tap it, right? That's the advantage. The disadvantage is it's very expensive over short distances. Kasi imagine you have to roll the cable, right? You cannot
That's your
bend
question.
it.
So
Yeah,
how come, yeah, if it's easier to break, how does that make it more secure?
because if it's broken, then you know that
Natamper,
some
ganun.
it's tampered, right? So it's what
Okay.
yung term is called tamper evident. It's
Oh,
like those stickers they put in parang please do not tamper, they put a sticker, right? Then if you try to break the sticker, like when you go to concerts, these wristbands, right? If you try to break it, that sticker gets super destroyed. So that if you try to tape it back together, it is tamper evident. So fiber optic cables, you can think of it as tamper evident, right?
wait. Thank you, sir.
All right. Sige. Then the second disadvantage is, of course, it requires highly skilled installers. That's the reason why we don't have a lab exercise that says, please create a fiber optic cable. You normally need specialized equipment to splice fiber optic cables. As a matter of fact, if there is a fiber breakage, say in Metro Manila, you actually see a whole van parked on top of a manhole or right beside where the cable is. And one end of the cable goes inside the van and the other end of the cable goes out the van because there has to be specialized equipment. Hindi siya pwede lang na may lineman lang na aakyat ng poste, fixes it hanging. No, you need special equipment for that. So it just not need highly skilled installers. Equipment is specialized as well. And of course, adding nodes is difficult, right? You can't just add a node into a middle of a fiber optic cable like a coaxial cable. Fiber optic cables are normally point to point. You have one node at the end, one node at the other end. Therefore, if you add another node, you have to have another point to point connection. So fiber optic cable, like UTP cables, are point to point. Okay? So that is those are the advantages and disadvantages. See, so some disadvantage. This is one of those disadvantages. You notice you see these rings. Kapag, I mean, if you stare at the post right now, you see these rings of wire. Have you ever wondered why they create these rings of wire? Parang sayang naman ng wire, hindi ba magastos yan? The reason why they create these rings is number one, it is more costly to cut a fiber optic cable, remove the ring, the extra wiring, and resplice it together. Mahirap gawin yan. Right? Because as I mentioned to you, brittle kind of fiber needs special equipment to connect. The second reason is you cannot bend it. So if you have an extra chunk of cable, the only way to make it look presentable in a post is to actually roll it like this. So you see these rolls, roll, right? So instead of cutting the wire, they simply roll it up. Now, this is not a fiber optic, this is a fiber optic cable to a house, for example. So it's rolled kasi may extra siya. So yung one end is you can pull it at the other end, or you can just roll it. Kasi cutting is not an option because splicing fiber optic cables are difficult. Okay? So, we have three major types of wired media. You have your electrical wired cables, which is your UTP cable, and your coaxial cable, and you have your optical cable, which is your fiber optic cable. Now, fiber optic cables carry more bandwidth. They're tamper evident, therefore they're more secure, but they're also harder to handle, while UTP is easier to handle. Therefore, in terms of cost, for example, UTP will generally be the cheapest, followed by fiber, although the cost of fiber is going down. For usable length, fiber has ridiculous length, right? It's kilometers, while UTP is 100 meters. Coaxial is you can get higher, like 500 meters, but the thickness of the cable increases. So it gets thicker as your distances increases. Transmission rates, of course, fiber can carry more, the most actually of the three. In terms of flexibility, UDP is easier to use, right? And since it has no shielding and anything, it is also a smaller cable, so handling is easier and makes it easier in terms of ease of installation. Problema lang sa copper or electrical signals is electrical signals are prone to interference. So you normally choose a cable based on the scenario, and your quizzes will be like that, like what cable is best for that. And that's why you have to take note of these pros and cons and advantages and disadvantages of each, right? So then the questions would look like this. In terms of installation and logistics, how is it installed? What shielding level do you use? Is it inside the factory or nasa bahay lang? Is there crosstalk effects like motors and stuff like that, which is also related to shielding? More crosstalk or more impulse noise sources, the more shielding you require. And of course, how much speed you need, the cost, and how long it must be. So these are the major factors for selecting cables. Okay, questions on wired media before we move on to wireless? Okay, wala? Good, very good. Okay. So now we go on to unguided or wireless media. So again, as the word implies, wireless, wala siyang wire. So it uses electromagnetic spectrum or the airwaves. Now the airwaves can be divided into this. The same airwave we use for wireless, cellular, Bluetooth, all of that, even your TV remote control or your aircon remote control, uses the same electromagnetic spectrum. Kasi wala ngang wire. Therefore, the goal of wireless communications is to basically share as much of this electromagnetic spectrum as possible. All right? So, this is what your electromagnetic spectrum looks like. So, this is the whole spectrum, at least most of the spectrum, really low, right? Low frequency is you can hear it. If the frequency is low, it reaches your ears. Diba? Yung ear mo nasa between 20 and 20,000, right? So that is the low frequency. Low frequency is low enough that the vibrations you can actually hear with your ear. Now, as you move up, you hit the middle, which is what we call the visible light spectrum. So visible light spectrum is in the middle. Between low frequency and visible light, you have what we call the radio spectrum. This is what we use for majority of our use cases today. They're lesser than visible light, so you don't see them, right? They're high enough so you don't hear them, and they can carry your information. So this is what we call the radio spectrum. Now, above the radio spectrum before visible light is what we call your infrared spectrum. And this is why your remote controls, which use infrared, you can block them by putting your hand in front of it. Right? The closer to visible light, the more likely it is to block using your hand. As a matter of fact, all of these things you can block with your hand. The only difference is that ito si gamma ray, saka si cosmic ray, may cancer ka na. Okay? Okay, sorry about that. So this is your electromagnetic spectrum here in the middle. Now, of course, anything above visible light is potentially cancer causing. So UV, X-ray, gamma ray, cosmic ray. You can block it with your hand, but you can get cancer. So we don't normally use these, but we use this, right? The electromagnetic spectrum you can break down, and this is what your electromagnetic spectrum looks like. You have very high frequency, up all the way to UHF and SHF. So that's the difference in terms of frequencies instead. The whole point is this is a limited amount of bandwidth from 100 megahertz to 6 gigahertz that you have to share, right? If one person is using it in one particular geographic location, other people can't use it unless you share it, okay? So that's the first thing. And of course, just a quick lang before this, but we do have a separate lecture where we discuss this in a little more detail. Some examples lang, just so that you have some reference. So your IR is your TV remote control. Your microwave oven is around, probably around like the 500 megahertz level, which is actually the same as your cellular signals. Your cellular signals are anywhere between 700 and I think the biggest we've seen today is something like 3 gigahertz, right? Your Wi-Fi is 2.4 gigahertz or 2,400 megahertz up to, and you have another band at 5 gigahertz or 5,000 megahertz. Your radio stations are at the VHF range, right? 89.9 or they're lower than the VHF range, so they're 89.9 kilohertz, right? Sorry, 890. Sorry, AM radio stations are 3 digits. So they're like 890 kilohertz. So they're below, they're very low frequency. While your FM radio stations are at the megahertz range. So 99.5, that's 99.5 megahertz. So that's at the below the VHF. Below the VHF. So this is VHF, they're here in this range, right? So AM and FM radio stations. The boundary between FM and VHF, so for example, VHF is where your TV resides. So your TV signals are what we call standard definition TV. And sometimes you have spillover, so meron din tayong mga UHF channels. So the former channel 2, for example, or ABS-CBN, GMA are probably here in VHF, while the more digital, the newer ones, like for example, their Studio 23 before are at the UHF range, right? So may mga channels ka rin dito. But of course, at this range, then may overlap ka na with cellular signals. Your Bluetooth uses the same frequency, or what we call um, I, ISM bands, so industrial scientific bands. So this is your 2.4 and 5 gigahertz, which can be used by many people without permission. That's why you can use Wi-Fi at your house without applying for a license, because the 2.4 and the 5 gigahertz range are what we call ISM bands, which are free for use for all, but you have to be using protocols that allow sharing of the frequency. And that's the reason why the same 2.4 gigahertz you are using and your neighbor is using as well, right? And that's the reason why when you look at your hotspot, you can see your hotspots and you can see your neighbor's hotspots as well. Okay? So wireless transmission can either be directional or omnidirectional. So on the left, you will see a picture of a cellular tower. There are some things that are notable here. The cell sites themselves, these are these long white things here that look like Neptune's trident. These are what we call omnidirectional antennas. That means they can point at one sector and they can cover a range, right? So they spread the signal across multiple directions. The smaller antennas you see here, the round drum-shaped ones, these are what we call directional antennas. They are put basically to put a focus beam of signal so that this tower can talk to another tower, right? That's what we call the backhaul in mobile communications. That's how remote and provincial cellular sites are covered. The signal from your cell phones here down below to your cell tower is omnidirectional. Then it is converted into a directional signal that goes to your ISP or your mobile cellular provider. Okay? So wireless environments can carry many types of signals, and these are just some of the examples. So cellular mobile is one, and it's the most common use. So you can run data networks. You can browse the internet over your mobile phone. Then you have what is called terrestrial microwave, which is normally point-to-point, right? So this drum-like antenna here is probably terrestrial microwave. So you send a signal from point to point, right? The distances can be longer, the bandwidth can be higher, but it is generally directional, or what we call unidirectional. Then you have satellite, which is the same as microwave, pero nasa space lang yung tower mo instead of on the ground. The nice thing about it is you don't have to worry about the curvature of the Earth, and you can cover a large geographical distance. The antennas are omnidirectional, so that you can cover a large swath of the Earth. But the thing is, of course, you share a lot more bandwidth with a bigger geographical area. And that's the reason why the amount of bandwidth carried is smaller. Then you have, of course, broadcast radio, which is basically single band, so one frequency carried by one channel, and that's it. Then you have your in infrared, which is also one way, which your remote control does. Okay? So let's look at terrestrial microwave, so which we also call point-to-point microwave. So basically, you have a microwave antenna on one end, microwave antenna on the other end, and you can send signals between the two. It can be anywhere between 2 to 40 gigahertz, so probably up to maybe 80 gigabits per second is probably what you can carry. The transmitter looks like a parabolic dish, as was shown a while ago. And it can be used by common carriers and private networks as well, right? So you can actually use this yourselves, but whenever you use terrestrial microwave, you need to license the frequency that's being used. But you can. I mean, you can go to the NTC, you can apply for a frequency, because it only covers a small geographical area, so the fees aren't very high, right? It requires unobstructed line of sight. So in the early days of the network in Ateneo, we used to use point-to-point microwave towers, basically to send signal to our campus from our internet service provider kasi hindi pa uso yung fiber doon. Yung problema lang is sometimes kapag may billboard na natayo or may puno that decides to become super tall, it can block the signal. And that's the reason why line of sight is required. The next problem is, of course, the curvature of the Earth. Since the Earth is curved, you need repeaters every roughly 30 miles apart. Okay? This is what it looks like. This is a long haul version. This is a big one. There's actually smaller ones that are probably 1/4 or less than 1/4, maybe 1/8 the size of this. Right? These are long haul microwave transmitters. They're directional, so they point the signal, a concentrated signal, on one direction. Now, if you want to see what this looks like in real life, you can go to Tagaytay. There is a microwave array there, right, along the ridge pointing towards Batangas, and there are a few of these drums attached to that. So those are microwave transmission antennas. Okay. The nice thing about microwave is no physical cabling between the sites. Imagine mo 30 miles, wala kang cable required, and you can send up like 100 megabits per second, or I think 40 gig is probably 40 or 80 gig is the best that we could get with point-to-point microwave. Depends on the frequency that was given to you. So the bandwidth is relatively high, right? And it can travel a long distance, and you don't need to build the infrastructure. Lalo na if, for example, you just want it to be one direction. Kaya the bandwidth is high because it's a concentrated, right? Disadvantage though, kailangan ng line of sight. You must be able to see from your site to the other site. Towers and repeaters can be expensive if you need to exceed more than 30 miles. And of course, it's prone to interference. So any type of interference can affect it, including rain in some cases, right? Of course, growing trees and billboards are the biggest pitfalls because it blocks your line of sight, right? So that is microwave, point-to-point microwave. Now, if we take the tower and put it in space, that is a satellite. So satellite is also microwave, but the relay tower, instead of being on Earth, is in a satellite in space. Now, of course, we can see the benefits naman of putting satellites in space, especially geosynchronous satellites that roughly follow where you are facing. So they're always on top of you. That means that you can send the signal through a longer distance because it's line of sight, right? You don't have to worry about the curvature of the Earth. And the satellite facing down can cover a large geographic area as well, right? So that's the reason why satellite links allow you to send signals with longer, even longer distances, right, than terrestrial microwave. It tends to be cheaper in terms of cabling, but of course, the cost of putting a satellite in space is not cheap, right? And maintaining a satellite in space. That's the reason why it generally is not a common option. And you would normally rent capacity from a satellite provider instead. You like rent a whole transceiver and say, I want 10 megabits per second. And you rent it from a satellite provider. That's the reason why satellite is normally used for broadcast, meaning one-way simplex transmission from the satellite down to Earth, send the programming to many, like the whole Philippines. If you want to cover the whole Philippines, satellite's the best, right? If you want to send TV programming to the whole Philippines, satellite's the best. The moment you need to do two-way, satellite becomes expensive because there are limited slots or limited capacity in the satellite to retransmit signals. But if you're broadcasting one signal to many people, satellite is awesome.
Sir, if a
And it would look
satellite
like this.
fails,
Yep.
does it stay in space? Or do they
Yep.
actually bring it down? Oh, okay.
Wait. It depends on the satellite. So we cannot generalize kasi iba-ibang klaseng satellite. But normally, itong mga TV satellites, they're normally built by consortia, like groups of users that send the satellite to space. And they normally have a provision for pushing the satellite to retrograde orbit so that the satellite will destroy itself. That is proper housekeeping of satellites. The problem lang is geosynchronous orbit kasi malayo yun eh. So parang ang gastos naman na if the satellite is old and they have to boost the satellite back to Earth to destroy it, parang it's too expensive. So most of the time, it's just left there. It's just turned off, but it's left there. It's space junk, right? But since there are only a handful of satellites in space, it isn't quite a problem yet. But I'm sure at some point in the future, magiging problem yan. Okay?
Thanks, sir.
Sige. So this is what it would normally look like. You have an uplink station, like a TV station, for example, direct-to-home TV like signal. You send the signal up to the satellite, and the signal can send it back to a downlink station, which is your satellite to your TV kung nakasignal ka, or the cable TV provider satellite so that you can share it with the cable TV subscribers. So this is generally how satellite works. Signal up, signal down. But since the satellite is far away in space, it can send the signal to a really large geographical area in Earth. So this is what I mean by large geographical area. So if you have geosynchronous satellite on top of the Philippines, look at the area it can cover. It can cover not just the Philippines, but Australia, Indonesia, Malaysia. And that's the reason why it makes sense to do like pan-regional satellites. So satellites are generally parang useful for more than one country kasi ito yung ito yung coverage area mo that covers the Philippines, right? So if you notice this, your geosynchronous satellite, it's actually 35,800 kilometers in space, right? So medyo, it's quite a lot, right? To cover quite a lot. This is just a list of satellites. The list is a bit old. I'll just set warning. I think this was last updated in 2017 pa siguro. So you will see the number of satellites in space depending on the locations. Just for your reference, there isn't a lot of satellites in space, right? And these are where they are located and the orbits in which they are located. So you don't see a lot of them. Okay. And of course, satellite transmission applications. Again, number one is TV or direct-to-home TV or direct broadcast satellite, DBS or DTH, direct-to-home. Right? Long-distance telephone is also used as satellite. So usually yung high-usage international trunks for long-distance. Pero right now, mas fiber optic cables na ngayon, but satellites are kept for backup purposes. And business networks, for example, the most common type of satellite use case we also see is what we call those satellite phones, right? You can think of them as a mobile phone, except they have way bigger antennas because the signal, instead of sending it to a cell site, it's sent to space. So medyo mahal siya per minute, but at least you can be anywhere in the Philippines and that phone would work. Right? The typical satellite bands, you have C-band, Ku-band, Ka-band, with Ka being the highest. Now again, the smaller the frequency, right? The bigger the wavelength, the bigger the dish, right? So C-band dishes tend to be very large because the wavelength tends to be larger. Then, for example, Ka-band, the dishes tend to be smaller, right? Because the signal is higher and the bandwidth is better, but the equipment is still relatively expensive compared to C-band. C-band is still the most common. We have some Ku bands, so the dishes are smaller, but it is prone to rain. Okay. Advantages of satellite, right? Again, at least compared to terrestrial microwave, can reach a large geographical area, has a high amount of bandwidth, right? Relatively, and it's cheaper over longer distances. So if we're talking about cover the whole Philippines, satellite's the best. But the disadvantage is high initial cost. Mahal magpagawa ng rocket ship at magpalagay ng satellite sa space because you have to rent space in a literal rocket ship to put a satellite in space. It's susceptible to noise and interference because it uses electromagnetic signal that the entire Philippines can hear. That's the reason why you do not do satellite communications without encryption, because everybody, whatever the satellite is squawking, the whole world can hear it, or at least that part of the world can hear it. So it's easy to eavesdrop. Then you have propagation delay, 38,600 kilometers. Quite far, right? That's why you have propagation delay. Right? Questions so far on satellite and terrestrial microwave? Okay, guys. Going once, going twice. Okay, so now we will cover the differences lang. So when you're talking about long haul or palayuan, which is better, yung pambato ng wired, which is optical fiber, and the best that the microwave can offer, our best that wireless can offer, which is the satellite. So let's look at it. In terms of theoretical bandwidth, right? You generally have 1 terahertz of bandwidth in optical fiber. Why? Because the whole fiber is dedicated to you. Share it with nobody. While a satellite will typically have only 36 to 72 megahertz. It's really, really far. So in terms of bandwidth, fiber by far can carry more. Right? Immunity to interference. Optical fiber is immune to electromagnetic interference. Right? It's shielded. It's only prone to visible light. And since it's cladded properly, there's none, right? Again, and it's tamper evident, as mentioned a while ago. A satellite, on the other hand, anything that satellite is saying is broadcasting, anybody can hear. So it's really not secure at all by default. That's the reason why you must include security of your own. That's the reason why encryption is used. Next, and that's on the part of the security portion. Problema lang is that optical fiber is point-to-point. As I mentioned a while ago, you can't just cut the fiber in the middle and add another recipient. Fiber is always point-to-point. So you need to add another point, put another point-to-point connection. While satellite is point-to-multipoint. You can have one satellite in space, one ground station transmits to that satellite, and many recipients, many ground stations can receive it. So it's cheaper for broadcast use cases. Flexibility is once you put a fiber optic cable between, say, the States and Philippines, that's it. It's very difficult to add another fiber of optic cable between the two. Or to say, I don't want to go to the Philippines, I want to go to Taiwan. Hirap nun. Yeah, most likely it's cheaper to just put another cable between the States and Taiwan. Right? So it's not flexible. Once a fiber is put down, that's it. A satellite, you can just move the satellite to another geosynchronous orbit and it can cover another geography in the world. It's very flexible. Right? For optical fiber, local loop is required. You need to put a wire to the users. Because again, it's point to point. While satellite, an antenna is easy to install. You can put a satellite dish and that's it. Right? And you can receive the signal. So here are the pros and cons between the two. If you really need to just send a large amount of bandwidth between 2 points, fiber is by far better. But for broadcast use cases where you have one signal sent to many people, satellite is better. Even though both of them can be used for each other's use cases, we normally use those. Okay? Here's a map of submarine cables in the world 2013. Right? There's a newer version. If you go to this website, they update naman this map fairly regularly. So if you notice, there's a lot of connections between, say, Europe and the States, and from the States to the Philippines. As a matter of fact, you will notice the Philippines is a very important, that Straits of Taiwan between Taiwan and the Philippines is a very important geographical meeting point of fiber optic cables. That's the reason why medyo marami-rami naman yung fiber optic cable na dumadaan sa atin. But if you notice, it's not that plenty. You can still count them with your hands, right? Let's zoom in a little more. This is what it looks like in the Asia-Pacific region. So if you notice, ang daming fiber optic cables, and most of them look like this because they're looped. Most fiber optic cables pass through many countries and they're looped. So in the Philippines, ang dami. But of course, they're like, I can count them with my hands. So they're less than 10. But there's still quite a lot relative to other countries. So Singapore, marami. Hong Kong, marami. Philippines, marami. This is Shanghai, Taipei, Korea. So Japan has plenty also, right? So the nice thing about our geographical location, we tend to be the preferred daanan point of fiber optic cables. Notice nearly all fiber optic cables pass this point between Taiwan and us. You did? So lots of fiber in this point. This is what we call the Straits of Taiwan, right? And this is also the point that is very earthquake prone. Kaya minsan-minsan, di ba, you'll read in the news, oh, bakit patay yung internet ko? Kasi may earthquakes sa Straits of Taiwan. Usually, these fiber optic cables get cut. Right? So this is a very sensitive point between the two. Right? And that's also the reason why you probably heard of this term, di ba? Luzon bypass. Medyo uso to, kaya naglagay ako ng current events for your class. Is because the Luzon bypass is basically, instead of passing through the Straits of Taiwan, which is up here above Luzon, below Taiwan, is we're creating actually a path where the cable lands in Baler, right, in the eastern seaboard of the Philippines, passes inside the Philippines, and goes out por Oro Point, right, in La Union, I think, right, and goes out to the rest. So that, and this one is not as earthquake prone as, say, the Straits of Taiwan. And since it is terrestrial, it's also easier to fix. I don't need to send a boat to fix it. So this is what you're reading in the news, right? This is what we call the Luzon bypass. And hopefully when this thing comes up, we will have a lot more cables that pass through. So we become like a transit point for fiber optic cables, okay? In terms of cables to the Philippines, right, you notice there's still a lot, but a lot of the big international cables actually land in Luzon. So either in La Union, Baler, Aurora. There's a lot in Batangas, right? So you can see the landing station actually if you go to the resorts there. It's a big nondescript building along the shore, right? So there's quite a number there. And there's also quite a number in Cavite, right? The reason why they're landed there is because the big populated area is Metro Manila. That's why it must be there. Then, of course, our service providers create nationwide backbones. So this is the backbone, the fiber optic backbone that connects the Philippines. Notice, hindi lahat ng islands nakadikit. So the rest of the islands that are not connected to the fiber optic backbone are connected using point-to-point microwave. And the only international cable not in Luzon is the one in Davao. I think this is the EAG, right? This is from the States to the Philippines. It's connected to Davao. Okay, so this is the map of fiber optic rails. Again, you can count the cables with your hands. One, and again, pair yan eh. So one in, one out. So actually just one lang yan. 1, 2, 3. Mga ano lang yan eh. Probably 7 or 8 major cable systems connecting to the Philippines. Okay? Questions so far for media? All right, so in summary, you have wired and wireless. Wired has a conductor, usually copper or fiber optic cables. Wired uses electromagnetic spectrum. Electromagnetic spectrum in particular use the radio frequency range. Right, for wired, it's a high bandwidth and easy to work with, particularly UTP. And the bandwidth is dedicated to that entire fiber. You don't have to share it. Unlike wireless, you share the entire electromagnetic spectrum with everybody in that geographical area. I have to share my 2.4 with my neighbors and so on and so forth. Right? Then the whole wired versus wireless comes to a head when you talk about long haul and high bandwidth. That's why you have fiber versus satellite, which are the two high bandwidth options for each. One is better for broadcast, which is satellite, and one is better for point-to-point or backhaul. We call that backhaul. Sending a lot of bandwidth between 2 points, fiber tends to be better. Okay, questions so far? So, ano yan? So, wired versus wireless. So, again, now we know the media in which the signals are carried. And the choice of media really depends on your use case. If you're trying to send TV signals, for example, you're trying to broadcast TV, EV signals to a lot of people, satellite is better. You're trying to connect a classroom, UTP is better. You're trying to wire your house, connect your house, two choices. Wi-Fi, I think, is better. So wireless is nice if there's just a few units in your house. But for certain rooms, for example, na hindi maaabutan or you need high bandwidth, then you can wire it with UTP cables. Then there's just a few use cases where coaxial cables are used. That includes your cable TV subscription because they already have a base of coaxial infrastructure. While, for example, broadband fiber is nice because it can carry high amounts of bandwidth, 30, 50, 100 megahertz. Okay?
Your question.
Yes.
Do you think that fiber would eventually replace all coaxial?
I think fiber has already replaced majority of coaxial use cases. So even, for example, yung cable, most of the cable TV operators' backbones are fiber. So we call it the hybrid fiber coax network. So nag-aano na rin siya. Parang it has already moved to a point that it does not make sense anymore to build to build fiber optic to build coaxial cable networks. And I think the industry has accepted that fact na rin. Okay? So maybe it will not disappear entirely though. I don't think it will disappear entirely. And I think because the cable TV vendors, kay Cable and Friends, nag-invest na kasi sila eh. It's already there, right? And just to be realistic, what is the amount of bandwidth ba they sell to you? 100 Mbps, 'di ba? Kaya naman ng kaya naman ng coax 'yun eh. 'Di ba? So there's no point in replacing it if it is still possible to use. Okay? Okay. So let us move on to ISO OSI. This one is relatively short, so I think should not have too much problems here. So do you guys see the slide? So it's set number 4, basic network features and the OSI model.
Yes, sir. See it, sir.
Thank you. Okay, so okay, good. So now we go to set number 4. So now we discussed how to convert, for example, physical things into data like pictures or video and stuff like that. We also talked about the actual transmission medium that we need to convert to bring data to and from each other. Now we're going to take a step back and let's talk about the protocols, right? So protocols are important because you need to agree on a language in order for people to communicate with each other. When you and I talk, we have to agree to say either speaking English, speaking Filipino, right? We cannot be going into a class and not knowing what language is going to be used. The language that's being used is actually a protocol. This identifies a set of procedures in which all things in the network, including hardware and software, agree to talk, right? So this allows you to define a particular standard. Now, we will look at two particular models, the OSI 7-layer model and TCP/IP. And as we know today, majority of the internet today, actually nearly all of the internet today is powered by a protocol called a protocol family set of protocols called TCP/IP, right? But first, let us discuss the OSI 7-layer model because it allows us to think of networking as a set of building blocks, right? And why are building blocks important? It's because it allows us to replace pieces of the network without replacing it all. So for example, when a new transmission media comes in, you don't have to replace the whole language, but you replace that part lang. Or if a new application comes in, you just create more additional protocols for that application, but you don't need to change the transmission media, the routing, the addressing schemes. So this allows you so a protocol architecture allows you to define certain things, right? Who's sending, who's receiving, how to identify. These are the basics, right? And how data is transmitted. And at the same time, you can break it down into modules. Each particular stack in the protocol will handle one particular aspect of transmission. You don't have to handle the whole thing. Kasi the danger kasi of making a monolithic protocol is when you change one thing, you have to change the whole protocol. But if you break it into modules with each module responsible for a particular part, then if something changes, only that part changes. Okay? So let's take a simple modular example. If I broke my file transfer protocol, so sending a file from me to you, into 3 pieces, and I will call the first module the file transfer module, where I talk to the application and give it a file. The second one is the communications module that checks if my transmitter is ready and your transmitter is ready, and we identify ourselves and we know who to transmit it to. And the network is basically, will it run on my fiber optic network or my wireless network, etc. So in this simple facility, simple example, if I wanted to create a new application called instead of file transfer module, I want to call it a chat module, I don't have to change the network access. I don't have to change whether wired or wireless. I don't have to change the way we identify whether we're ready to transmit. Are you ready to transmit? Am I ready to transmit? We don't have to change that. We only have to change this module, which is the application stuff. Instead of sending files, you're sending an audio stream. And the other guy receives an audio stream and sends back an audio stream. So you notice, by dividing it into 3 modules, whenever the application changes, we only change this module. Whenever the network, say, from wireless, I want to make it wired, we only change this module. So basically, it allows us to break down or evolve the network without changing everything. As a matter of fact, it even allows people to specialize. Ako, I only make network interface cards. I only care about layer 2 and 3, example. Or at least layer 1 in some cases. So this is an example 3-layer module. So in that particular example case, I call it application, transport, which says, are you ready? Am I ready? Let's send. And the actual network itself. Of course, the world is more complicated than 3 layers, right? So we don't have a 3-layer module in real life, a 3-layer model in real life. We actually have a different one, which is the 7-layer model. Okay, so the world has decided, okay, instead of everybody creating a protocol architecture themselves, let's standardize, right? So there are 2 that are very popular in the world. There's what we call TCP/IP, protocol family. It's widely implemented, right? And we have the ISO OSI model, which is widely known, but actually is only used for conceptualizing. It actually isn't a actual protocol itself, right? We don't say na my laptop is powered by the OSI model. No, it's usually TCP/IP, right? But the TCP/IP can actually be layered and can be studied in the context of the OSI model. As a matter of fact, all networking can be studied in the context of the ISO OSI model. That's why we talk about it, and that's why classes like mine use the OSI ISO model kahit na wala namang computer in the world that uses the OSI ISO model. So you can think of the OSI ISO model as the de facto standard, meaning it is the standard that the world accepts. It was standardized in 1984 by the International Standards Organization, whose job is to create standards. While TCP/IP is standardized by a group of people called the Internet Engineering Task Force, which is part of the team that designed the internet, which is a bunch of people who contribute ideas. I can contribute an idea to IETF. You can contribute an idea to this. There's no formal structure. And you can use any standard that's in IETF. It's very liberal. It's not a fixed standardization process, right? But it is used popularly in nearly all devices in the world, okay? But we still use OSI as what we call a thinking module or a framework in which we can discuss networks. And the OSI model is divided into 7 layers. And these are the 7 layers: the application layer, presentation, session, transport, network, data link, and physical. Okay? So again, this is a reference model. So don't expect to find it in actual equipment. But whatever protocol is being used, including TCP/IP, you can roughly break it down into the layers of the OSI model. So first of all, it is basically created to reduce complexity, modularizations. You can create standard interfaces for each layer, right? You can create interoperable technology, and it simplifies teaching, which is actually what I am using it for. So all people seem to need data processing. That's a mnemonic that you can use, but it's actually not too hard to remember: application, presentation, session, transport, network, and data link naman. And let's discuss each very quickly. So again, before we discuss each pala, the unit of information. So you can think of the OSI model as a stacked model. So you have your application on top, right? It is basically this module runs on the information first, then the information is passed to the presentation layer, the information is passed to the session layer. At these 3 layers on the top, it's simply called data, right? So the unit of transfer, or the primary data unit, or PDU, of that piece of information is simply called data in this layer. Once it sends it to the transport layer will break your data into smaller pieces called segments, right? Kaya segments is the unit of data transfer, or PDU, for the transport layer. Then the transport layer sends each segment down to the network layer. The network layer breaks the segment further into smaller, what we call packets. So technically speaking, the word packet should refer to network layer packets, not to transport layer segments, or not to data link layer frames. After that, the network sends the packets down to the data link layer. The data link layer breaks it down further into what is called frames, right? Then the frames are sent down to the physical layer. And physical layer, as we discussed, is only zeros and ones, kaya bits yan. So if you notice, data broken down into segments, segments broken down into packets, packets broken down into frames, frames broken down into bits. Bits sent across, right? Then the bits are assembled, thrown up into a frame, reassembled into a frame. Frames are brought together, reassembled into a packet. Packet comes together, reassembled into a segment. Segment comes together, reassembled into quote-unquote data, which is used by the upper layers. So that's how the ISO model works. You always start from the top, breaks it down to smaller pieces, right? Then they're sent across the wire as bits. They're always sent across the wire across bits, and they're reassembled, right? And we will cover a little more of that later. So let us cover the first layer first, which is the application layer. So the application layer refers to the actual application itself. If it's file transfer, right, then it's used to transfer files. If it's electronic mail, used to send email. Terminal emulation allows you to remote control another machine. And those are what we call applications. Now, applications only matter to humans. They don't matter to data transport. The data transport layer doesn't care about the application. It's us who uses the application. So the main interface of application is the program itself, hence the term application. So web browser, for example, is the application for web surfing, which protocol in TCP/IP is called HTTP. For sending files, for example, the file transfer protocol, you have a file transfer application. For secure shell or secure remote terminal emulation, then you use an application called OpenSSH, or PuTTY in case of you who are familiar with using OpenSSH application. So that is the application layer. The application layer is responsible for interacting with the user and the application itself. Now, we break down, after we talk about specific application, all the information and all the data has to be represented in a certain way. So there's what we call the presentation layer, which is responsible for something called data representation. For example, is the data an image? If it's an image, is it GIF, JPEG, right? If it's a text file, is it in ASCII? Is it in UTF-8? Is it in UTF-16, right? Or if it's a video, is it in is it in Vorbis? Or is it in MP4? Ganyan. So that is what we call data representation. Layer 6 simply means that this layer is responsible for determining what type of data or data structure is being used. Okay? Then you move it down after you know what data is being used. And the reason why data representation matters is because you have to properly identify the data. If it's in ASCII, you have to tell that it's in ASCII because the other system has to know it's in ASCII kasi kung UTF-8 siya, kailangan niya i-convert to ASCII. Right? So protocol conversions are handled by the presentation layer. Now, the session layer is what we call host-to-host communication. You need to identify who is talking to who. So me, if I'm doing a chat with you guys, for example, in this particular Hangouts call, I am the one talking and I need to know that you guys are talking. So I will identify you, and I can identify you by looking at the screen and looking at your names, for example. You have your names in the screen, and that's how I identify you. So that is what we call session layer. Now, in the Hangouts call, it's not too parang personal. We don't identify individual people, right? However, if you make a phone call, you need to identify a person. So you can identify them using hi, hello, hello. This is William. Who are you? Yeah. So that's how you can identify. All of that is what we call session layer protocols. Now, session layer can get complex because it can also include things like encryption. For example, you visit a website and you want to visit that website, say mobile banking or internet banking, at gusto mo secure, right? So you look at the HTTP connection and you actually see if it's secure, right? That interaction, the interaction to determine if the connection is secure or not, and you're really viewing the website that is what you intend to view, that is handled by the session layer. So session layer establishes session between people to people or people to systems, right? So they are basically a higher layer abstraction of that allows you to identify the parties that are being talked and to secure the communications between the two. So kung may encryption, for example, session layer yung responsible. So for example, for web surfing, HTTP is the protocol that's used to define the protocol for web surfing. That's the application layer protocol for web surfing. SSL is like a session layer protocol that ensures that the communications between you and that website is secure. Okay? Then we move on to transport layer protocol. So transport layer protocol is probably the first of the protocols that is actually very network specific already. This concerns with the actual transport of data. And that's the reason why the data from the session layer is broken down into smaller segments. Because smaller segments are standardized in size and they are easier to handle, right? So for example, if a piece of data, for example, is 5 megabits per second, if I start 5 megabytes, for example, if I start sending the 5 megabyte file, and for example, at the 4.9 megabyte point, naputol siya, then I have to resend the whole 5 megabyte file. Sayang naman, di ba? So that's why you break it down into smaller segments. Kasi, sige, I'll break the 5 megabyte file into, let's just say hypothetically, 5 pieces. So tigwa 1 megabyte yung piece. Para kung 1 megabyte sent, succeed. Okay, next, send the second megabyte, succeed. Send the third megabyte, oops, nag-fail. You only resend the third megabyte, not the first and second. So breaking them down into smaller segments allows you to manage the flow of communications properly. That's what we call flow control, right? You can say, I want to break it down into 5 pieces. Here's the first of the 5th piece. Tell me when you get it. You got it? Okay, I send the second of the 5th piece, third of the 5th piece, fourth of the 5th piece, 5th of the 5th piece. Kapag si recipient nakuha na niya yung all 5 pieces, it can reorder the pieces kasi syempre sometimes the third piece arrives before the first piece. It can reorder the pieces and can say, check, I have all the pieces and I can reassemble the communications. That is what we call flow control. So it handles things like fault detection. Kung may kulang na piece, it reorders the data, right? Ensures it's in proper sequence. And it is the one who handles retransmission as well. Now, for higher level use cases, it also is responsible for ensuring that virtual circuits are managed, right? That I am sending from one host to a particular host and not to any other host, right? So that's transport layer. The main job is flow control, ensuring that data is transmitted reliably and it gets to its source. Now, depending on the transport layer protocols, you can actually even tell the transport layer to ignore reliability, right? So that's also the beauty. It's responsible for it, but you as the user can choose whether you care about reliability or not, depending on the use case. Then we go on to the network layer, which is responsible for simply two things, addressing and routing, or addressing and choosing the best path. Now, the network layer, so addressing, this is what we call logical addressing. So a telephone number is an example of a logical address. It's assigned to you, and it can tell you the best path to get to the number. Oh, it's in the Philippines, it's in Metro Manila, it's in PLDT Exchange Diliman. It's a phone inside the PLDT Exchange in Diliman. That is addressing. Now, in TCP/IP, the addressing mode is called IP addressing or Internet Protocol addressing. And the IP address is normally represented, at least the version 4 IP address is represented as a quad decimal number between 0 and 255, right? So 192.168.0.1, for example. Or the Ateneo website is 202.138.130.160 yata, right? So that is an IP address. It's used to address a website. Now, IP addresses, unless they are non-routable, are unique in the entire world. So for example, the Ateneo website address is unique in the entire world. So nobody else except Ateneo can use the Ateneo IP address. So that is what we call logical addressing. It's an address assigned to a logical organization like the Ateneo University or your internet service provider. Then of course, once you have addresses, you are now able to choose the best path. Of course, yung mga DSL or mga broadband natin, mga fiber natin, wala namang choice. You just have to send it to the ISP. Your laptop's connected to your Wi-Fi has no choice but to send it to the Wi-Fi router. But in more complicated networks, there are more than one path, right? And this network layer protocol, so any decision making that allows the selection of path is a network layer responsibility. And we can discuss, and we will definitely discuss that in much, much, much more detail later on. But definitely it is a layer 3 function. Then we move on to layer 2, which is responsible for, okay, so transport layer, diba, segment, breaks it down into packets so that it can handle the network. Each packet is given an address. So my from, saka my to, saka which application on both ends, right? That's on the network layer. Once the network layer, okay, it's time to send it to the actual physical media. But before we convert it to zeros and ones, we need to be able to know, for example, what type of what type of transmission network is there at the bottom. So that is the responsibility of the data link layer. It's responsible for bridging an abstract packet and making sure it becomes bits, right? Zeros and ones. So now this is responsible for what is called physical addressing. So your data link layer, a major component of the data link layer is what we call your network interface card. For every device that's connected to a network, you have a network interface. The network interface is something called a media access address, or MAC address, right? The MAC address is an example of a physical address. Can you change your MAC address? Hypothetically, no, you're not supposed to, but sometimes you can. But you're not supposed to, right? Because it is actually tied to the manufacturer who made your device. The reason why MAC addresses are unique is because within your, say, Wi-Fi network or within your switch in the house, dapat lahat ng MAC addresses ng devices dun unique, right? Because it allows everybody in your local area network to see each other. That is the responsibility of the data link layer. That is what we call physical addressing, and it also has its own concept of flow control once it sends frames. So the packet is broken down into frame. Each frame is addressed with a physical address. So instead of an IP address, meron siyang dagdag na envelope. So each packet, may IP address na, broken down into smaller frames. Each frame, linalagyan pa ng envelope, linalagyan ng physical address, right? And the destination physical address as well. Then that is sent to an electronic component in a network interface card or the MAC layer that breaks it down into zeros and ones, and that is sent to the physical layer. And the physical layer, wala siyang trabaho but sends zeros and ones. That's actually the media layer. All right? So this is where you send it to the wire or a connector, or you send it through wireless. And basically in this realm, it's just a question of voltages. If 5 volts equals 1, negative 5 volts equals 0, etc. Right? So that's the physical layer. Right? And that is it for the 7 layers of the ISO OSI model. So just as a recap, application layer deals with application-specific functions, whether it's browsing, texting, sending email, messaging, whatever. But it's specific to what we need from the network, application yan. If we talk about data representation, protocols, formats, codecs, etc., that's presentation layer. If we talk about host-to-host communications or person-to-person communications, like are you authenticated? Are you William Yu? Are you Far East Bank? It does not exist anymore, actually. So that's session layer thing. The transport layer is ensuring flow control, making sure the data gets to the other side, right? So it breaks it into smaller pieces to make it more manageable and make sure that each piece gets back and is reassembled properly. Then it's sent to the network layer, whose really job is to make sure each of these pieces get to its proper destination. Now, a segment is generally broken down into packets, or sometimes they are not further broken down. Depends on what the network supports well. So certain sizes of traffic supported by the network well, and that's why it's broken down further into packets. And each packet is addressed with a logical address, like an IP address, and sent across the best path. Now, the things with certain networks like TCP/IP, it's just your best guess of the best path, and hopefully dumating yung packet na yan sa destination. Pag dumating na sa destination, that's when it's reassembled back into a segment, sent up the protocol. Then the data link layer basically breaks it down into something that can be accessed by the media, right? Because again, physical addresses are not understood by equipment, but equipment have what is called logical addresses. So they're broken down further into frames, and the frames have logical addresses. Then once it's sent to the electrical connector, zeros and ones to siya. Okay, questions? Yeah, so that is quite a handful, but the material is fairly simple. And of course, the quiz questions here lang naman is what layer is responsible for what? So, hindi naman masyadong mahirap yan. Okay, let's take a look at layer 2 in a little more detail. Kasi itong layer 2 yung usually where the confusion is, right? So, layer 2 is actually defined by another standard called the 802 project of the IEEE, because layer 2 is actually already electromagnetic in nature. It gets your logical packets and converts it, it's responsible for converting it into electromagnetic signals. That's why the 802 project was created. Right? The 802 project is very rich. It has a lot of things. For example, the Ethernet networking or the wired networking we use today is called 802.3. The high-speed version is called 802.12, for example, right? Now, we also have different types of networking, like a bus version is called 802.4, not so common. The token ring, which I explained in our last meeting, 802.5, is actually quite common for industrial use cases. Then we have another type of, another form of the 802 standard that is super popular. That's 802.11. That's your wireless networking. So the 802 standard is actually very popular. As a matter of fact, this is the face of the devices that you actually buy. I need to support a Wi-Fi device. That's an 802.11 compliant wireless device. Okay. The data link layer is broken down into two layers. So this is how the 802 project has defined it. We have what's called the logical link control and the back address layer. Now, logical link control is responsible for basically determining, for example, who the source and destination is. And again, at that layer, right, at the 802 layer, they don't understand IEP addresses. They only understand physical addresses, which is your MAC address. So you notice there is this destination address and source address, the protocol, and the data inside. So this is what the frame looks like. So this is the data. So it's from the packet. It's broken down to smaller chunks. You add the source and destination address. That's the simple version, right? So Ethernet was the original protocol that was created by 3Com, which is a company that's now part of HP, right? It was invented by a guy named Bob Metcalfe, who was the founder of 3Com, right? So he invented local area networking. And the standardized version is what we call 802.3, right? So Ethernet is actually a trademark of 3Com, while 802.3 is the actual standard, but most people simply call it Ethernet, right? Now, Ethernet simply this: you get a frame, right? You get a packet, break it down to smaller data bits, and you slap in a header, right, which has the source and destination, and you put a checksum so that you'll determine that the frame is intact. This way, you can check whether after it is converted into zeros and ones. So this thing is converted to zeros and ones and sent across the wire. Once it's sent across the wire, the other side will receive it and reassemble it. It can use the checksum to determine if this data is intact. Then, of course, there are extensions to the protocol. These are what the extensions are. So logical link, so this is actually the MAC layer, right? So physical addressing layer, right? And this is the LLC, or the logical link layer, which has an additional flags, right? So this will determine readiness, I'm ready to send, etc. So we call that signaling. right? So it manages the upper layer communications amongst different SAPs, or actually, we don't use the term use. Those are just things connected to the network. So computers, for example, have a network interface. Those are the ones that are connecting to the network. So each network interface in your computer is unique. So if your computer has 3 network interface cards, may 3 MAC addresses carried. As a matter of fact, your physical computer will probably have a physical MAC address and will have a wireless MAC address at least. Even your Bluetooth has a MAC address that's separate from your Wi-Fi MAC addresses. So each of those is a network interface. Each of those is a service access point. Okay? And it's defined by the 802.2 substandard of the 802 project. The MAC layer, again, if you notice, just slaps in the physical and the physical addresses, source destination, and what is called the checksum. Para pagdating ng packet sa kabilang side, pwede mo assemble. And once you assemble the frame, sorry, not packet, frame, you can look at the checksum, you can compare it with the data. If there's something wrong, you can re-request the frame, right? So it allows you to guarantee that the frame is intact before you process it and assemble the frames further back into a packet and throw it back to your operating system. Okay? So medyo confusing yan to a point. Are there any questions so far on 802? Basta it's responsible for 2 pieces, making sure the other guy is ready to send. Because remember, this is layer 2, your equipment. I'm going to talk to the wire now. Are you ready to receive me? Yeah. And at the same time, it also contains information that can address it. This is from this frame is from me. This is my MAC address. I want to send it to you. That is your MAC address. And this is the checksum so that you can check if it's intact. And the actual flow of data would be the application layer, as I said, would be data. Presentation layer would still be data. You just have to encrypt, convert, or whatever it. Session layer just puts an address. For example, in an email, you put the email address. That's session layer stuff. Then it's sent to the transport layer as data. The transport layer gets it, breaks it down to smaller segments. The segments are sent into the network layer. The network layer breaks it down to packets and slaps a logical address for each packet. Network layer sends it down the data link layer. The data link layer gets the packets, breaks it down further into frames, and slaps an address or a machine address or MAC address in the case of project 802 into each frame and also puts a checksum. Then it looks at the wire it's connected to and converts that entire frame into zeros and ones. The zeros and ones go to the local area network. And if, for example, if all of these 4 devices are connected, or these 2 devices are connected, then the zeros and ones are received by all the devices in that particular switch or that wireless network. So the physical layer of all those devices receive it. They start to assemble it until it reaches a frame. Once it's a frame, they look at the frame. Is the address from X, from this guy? Then the recipient, the destination should be, if the recipient is somebody else, you ignore, or you what you call drop the frame. If the recipient is you keep the frame. Then you start assembling frames until you have a second frame, third frame. Oh, this is frame number 205. Let's wait for the rest. 105, 305, 405, 505. Oops, buo na yung frame ko. I assemble all the frames together and I have a packet. Then the packet is assembled by the data. So each bits come out, send it to the data link layer, assemble it into a packet. Once I have a packet, I look at the packet. So communications devices like routers only live up to layer 3. So they look at the packet and says, the source IP address is X, and the destination address is not me. I drop the packet. If the destination address is me, which normally is the case in these cases, I say, okay, then I make a routing decision. This packet should go to the next part of the network, which is this router. So I change the destination and I say the destination should now be this, that send it to this. So I say that it should go to that router, sends it back to the data link layer, right? The data link layer gets the packet, breaks it down to frames again, slaps the MAC address to the frame. But now, instead of the destination MAC address being me, this particular router, it sends it to the next hop in the network, which is this router. So the frame is replaced, the destination address is replaced by this guy's destination address, converts to zeros and ones, sends across the wire. All devices start to receive the zeros and ones, assembles it into the frame. If the frame does not belong to me, discard. If the frame belongs to me, sends it up to the data link layer. Assemble the frames until it's complete. Look at the MAC address, right? Then once the frames are complete, sends it up to the packet. Oh, this has to go to a host that's in my network, right? I send it back down. Then it's sent to the actual host. receives the bits to assemble a frame, looks at the frame if it's mine. If it's mine, assembles all the frames, sends the packet, looks at the packet if it's mine. If it's all mine, sends it up. The packets are assembled into a segment. All the segments, check if all the segments are complete. Kung kompleto, then move it up to the application. So this is what is done. So your computer will always be from layer 7 if a human is involved. But if it's sent to different devices in the network, it sometimes goes up all the way to layer 3, or sometimes layer 2 lang. Switches and hubs are layer 2 lang. Sorry, switches pala. Hubs are physical, so they just get it physical, tapos pinapasa lang. Okay? So this is how PDUs and data flows happen. Again, this is what we call segment or transport layer packet data unit. This is packet, frame, and bit. Okay, questions? Okay, let's do an example quickly. So an FTP, I use an FTP program as a send file, right? So I talk to an application layer of that the communication. So the FTP program. The FTP program gets my file and says, oh, is it in the correct format? Naka-ASCII ba siya? Kasi text file. Oh, ASCII, check. Sends it to the session layer. Session layer says, who's supposed to receive this? User ID 12345. Okay, this file can only be accessed by user ID 12345. Mark it and send it to the transport layer. Transport layer breaks it down to segments and labels them properly. Flow control, 1 of 2, 2 of 2, etc. Sends it down to the network. The network, okay, breaks down the segment into packets and sets a source IP address and the destination based on what is the next destination that it selects best based on routing decisions. Now, routing we will discuss later, but this is made by the network layer. So when the network layer already says, hey, I'm connected to that router over there, let's send it to that router, puts the physical address, the logical address of that router in the destination and passes it down to the data link. The data link reassembles the packet and says, hey, this destination address belongs to that router that's connected to me. I break down the packets into frames and attach the source MAC address of the source computer, which is us, and the destination to the next, the physical address of that router. Then I get that entire frame. Then I stream it as zeros and ones on the physical layer. At the other side, and let's just say the other side host gets it, assembles the bits until I form a frame. Once I have a frame, the data link layer assembles the frame, excuse me, looks at the frame and says, hey, the frame does not belong to me, discard. Or the frame belongs to me, assemble. Once the frames are complete to form a packet, it reassembles the packet and sends it up to the network layer. Once the network layer looks at the packet and says, is this packet mine? Does it have my logical address? Yes, I keep it. No, I don't. Then if I keep it and it's mine, I pass it on to the transport layer. Transport layer reassembles it, looks at all the segments and reassembles them. Once I have enough data, I pass it on to the session layer. Session layer checks, is this for user 123? Please log in as user 123. Yes. Passes it up. Oh, this is in ASCII. Display it in ASCII format. Do you need to convert? No, because I support ASCII. Pass it up. And the application allows the end user to download the application. So that's how for example, TCP/IP works within the context of OSI. So OSI is just a way to discuss networking, and each little bit of the networking stack focuses on one portion of the OSI protocol. And 7, I think, is more than enough to discuss it all, right? But in reality, we don't actually use 7 layers of OSI model. We actually simplify it, right? So TCP/IP model is a 4-layer model, sometimes 5, depends on the book. So basta for sure, the top 3 layers, application, presentation, and session, is simply grouped as something called the application layer. And that's the reason why you have no PDU format for presentation, session, and application. It's just called data, right? Transport layer is transport layer in both, and the PDU is called segment. Network layer is network layer in both, and the PDU is called the packet. And the network interface layer is a combination of layer 2 and layer 1. This is actually called the frame. And it also sends the bits on the physical layer. However, some references or some books call this 5 layers, where this network interface is still broken into data link and physical, right? So it depends on the book you're reading, maybe 4 or 5, but for this class, it's 4, right? And if you notice, they can be mapped cleanly into the OSI ISO model. That's why we can discuss it in terms of the 7 layers. Oh, that's a layer 7 protocol. That's a layer 3 protocol. So later in class, we will use that a lot. And that's the reason why these definitions are important, because we're going to use it upon discussion in the class, right? So TCP/IP versus OSI. So most production software, as I mentioned a while ago, use TCP/IP. So has OSI lost the war? Well, really, it was really not really meant to be a practical protocol. It was a reference model. The practical protocols were implemented in other standards, which did not become as popular as TCP/IP. Two is it is unnecessarily complex, right? It is 7 layers, and in the best of books, TCP/IP only has 5. So why break it into more layers than necessary? As a matter of fact, when we talk about protocols in TCP/IP, we just call them application protocols. We don't call them session transport protocols. So these application protocols. So HTTP, SMTP, etc. All of these TCP/IP protocols are application layer protocols. On the other hand, transport layer protocols in TCP/IP are transport layer protocols. TCP, actually, or transmission control protocol, is a transport layer protocol, while IP is a network layer protocol, right? So Internet Protocol or IP is a network layer protocol. Then, of course, you have your Project 802, which is actually your layer 2 and your layer 1, right? This is what's called the network interface protocol, because the network interface card is responsible for both media and the actual, the actual media conversion as well, or flow control at the layer 2 level. Okay, but we still study it because it's nice, it's modular, and it allows us to talk about the layers, which later on we will talk about the layers and the rest of the class. Okay, so that is it for today. So we are 7 minutes off schedule, pero at least na natapos. Any questions so far? Right, very good. So ano
Sir,
naman,
for
very
the lab,
straightforward naman yung klase.
for
Sorry?
the lab, we don't need a tester, right? We can just use connect it to our internet and show that if it works, then that's enough.
Yep, yep.
Okay.
So yung tester, medyo mahirap bilhin yung tester. Actually, hindi na mahirap, but it's the most useless thing after the fact. I mean, you don't really need to test network connectivity all the time. So you can just plug it to your computer and plug it to your router. If your internet works, then I believe it works. Basta you just video yourself doing it lang. Kasi I'll see naman if you don't do the cabling properly, if you don't sequence the colors properly, I will know naman that it will not work. So you show me the colors, right? So when you do the video, you show the video the colors. Okay? So pass or fail lang naman yan. It's 100 or 0 lang naman yan. So just make sure you submit on time para maging 100 yan. Okay? Just take note na lang, you're looking at Moodle right now. So, no? So please take note na lang. This is lab exercise number 1, cabling. Right? So you see this, right? So these are the requirements. Just follow the instructions. They're fairly straightforward. Ignore this na lang yung -10, -10. You can try as many times as you want. I'm not going to minus you. And it's not in groups of 2n anymore. Just make sure you crimp it properly and it just works. Okay?
Sir, so we have to do both the T568A and B.
The instructions. This is just the procedure, but if you read the instructions, you only have to do B.
Okay.
It's
Thank you,
actually
sir.
it's here. It's actually basta 1 lang, B lang yata. B. Let's see. Yeah, B lang here. The goal of the exercise is to create a straight patch cable using EIT TIT 568B wiring format. Okay? And that's the reason why I don't suggest you risk it. If you have an existing cable and you cut it and you just crimp one end, you're not sure kasi what cabling convention that cable used. If you bought it from a store, malamang it follows this. Because this is what the world agrees should be the default cabling sequence. But again, you'll not know. So it's better you normally crimp both ends para sure ka. Okay? But you can crimp one end. If it works, then good. If it doesn't work, you crimp the other end. Okay? Right. Anything else? No more questions. Ayun. So at least we end early today. So please take note, lab exercise, again, 2 assignments, and 1 quiz next meeting. Right? So if there are any questions, just let me know. Tapos next meeting, I'm going to post a Zoom link. So hindi na tayo mag-hangouts meet next meeting kasi the recording feature of Hangouts will disappear at the end of this month. Wait, sorry. Next meeting is still, ano ba yung next meeting? Next meeting pwede pa. Right? So next meeting yung last meeting na mag-hangouts tayo. Pero after that, magpo-post na ako ng Zoom link. So for now, mag-hangouts tayo today, mag-hangouts tayo next meeting. Okay, so same link pa rin. Alright, people? Anything else? Violent reactions, questions, ganyan? Wala na. Kung wala na, so thank you very much, guys. See you next meeting and good luck with the rest of the activities. Again, open notes for those who missed the start of the class. Wala namang requirement na kailangan close notes itong mga assignment or quizzes. As a matter of fact, the problem with these impersonal classes is sometimes there might be some material na na-miss during the discussion, so you may have to research a bit yourself. Okay? Right. Very good, very good. So glad to hear that. Ayun. So ano naman, actually even in the regular version of this class, hindi naman siya closed notes. Ano lang is that you just have the 10-minute limit, right? So you can't take forever to look for the references. Okay? Good luck, guys. Thank you very much. Bye.
Thank you,
Thank
sir.
you, sir.
Sir.